Hi there. So we need to find the value when the area bounded by y equals the square root of x and y equals x over 3 is rotated about the y-axis. Okay, so first and foremost, as elementary as this may seem, it's nice to graph the curves, right? So the red represents y equals the square root of x, and the blue represents the linear function y equals x over 3. And shaded in black is the region bounded between them. So the key here is when we rotate this thing right about the y-axis. All right, so right, what's gonna be the graph? Could have drew it a little better, but I think you get it. Okay, so let's define some terminology first. So we have disk and washers, right? So when you rotate for disk or washers about the x-axis, right, this equation is going to be pi times the integral, right, a to b, those are two different x values, of the large radius squared minus the little radius squared, if there is an inner radius. When you rotate it about the y-axis, right, it's the same thing, but it's going to be dy. Washers have an inner, smaller radius, lowercase r, and discs do not. So sometimes the equation, right, may not have an r square, a lowercase r square term. And then we have shells. So shells rotated about the x-axis, right, is going to be 2 pi the integral a to b rh dy. Rotated about the y-axis is 2 pi times the integral a to b, right, radius times height dx. So that's what I'm going to write. So r is the radius and h is the height. Okay, so when we look back at, right, our figure, right, we have this radius, and then we have this radius. All right, so this is lowercase r. I'm going to denote this to be capital R. All right, so we're working with washers. Okay, washers rotated about the y-axis. Right, it's going to be the second one, so it's going to be pi times the integral something to something, right, something squared minus something else squared dy. So believe it or not, that's about 33%. We're 33% complete, right? We just have to figure out what goes into the bounds and what our radii are, and then we just have to evaluate the thing. A lot of times they just want you to set it up, but in this case we can evaluate it. So since we're working with dy, where I'm going to rewrite these two equations and solve for x. right? So this says that x equals 3y, and this says that x equals y squared. Okay, so capital R, right, that's y equals x over 3. So that's the same as x equals 3y. So we get 3y squared minus, right, so this one must be y squared. Okay, what about the bounds? So I'm going to equate 3y with y squared. Right, we have to find out what this intersection point is right here. Okay, it's quadratic, subtract 3y from both sides. This is 0. We can factor out a y, we get y minus 3. So if y is 3, right, I did a little neater for you. Then x, right, y equals 9 divided by 3, or y equals the square root of 9. Excuse me, or x equals 3 times 3, or x equals 3 squared, which is 9. Right, so this point is going to be 9, 3. So along y, right, the lowest this area goes is 0 at the origin, and the highest it goes is 3. So this is a 0, and this is a 3. Now, how we chose shells, should I write this in black because I'll circle it. Right, we know it's going to be 2 pi times the integral something something dx. So again, we have to find out our radius, the height, and what goes in for our bounds. Okay, I'm going to erase this on a graph. Okay, this, right, is our radius. So we're just going to call this x. Now the height is going to be the top minus the bottom. So the h is going to be the square root of x minus x over 3. Go back to board 5. So radius and our height, square root of x minus x over 3. And what about the bounds? So along x, we're going from 0 to 9. 0 to 9. All right, so I assume you know how to take it, basic antiderivatives. And for both answers, for the shells and the washers, right, they come out to be roughly 101 0.79. Here, actually, I take an antiderivative. So let's see, 9y squared minus y to the fourth. I know a lot of times they do want exact answers. So I'll work off the washer one. 0 to 3. Reverse power rule. 9 divided by 3, that's 3. 2 plus 1, that's 3. Minus y to the fifth over 5. Take this from 0 to 3. Don't forget the pi. Plug a 3 in. 3 cubed is 27 times 3, that's 81. 3 to the fifth, let's see, that's 9 times 9, that's 81 times 3, 243 over 5. Don't forget the pi. 405 minus 243. So we get 162 pi over 5. Just check with my calculator. Yep. All right, I hope this helps somewhat. Let me know if you have any questions. I know it was a pretty long process, but do more problems, become second nature to you. Have a good one.